Here we have an infinite series with the expression n over n plus 1 factorial, and I'm going to use the ratio test to show that this series converges, and then also show that this series converges to 1. So here let a sub n be the expression n over n plus 1 factorial, a sub n plus 1 be n plus 1 over n plus 2 factorial. The ratio of a sub n plus 1 and a sub n will be this expression dividing by n over n plus 1 factorial. This n plus 2 factorial, we can rewrite it as n plus 2 times n plus 1 factorial. Here we have the factor n plus 1 factorial, and then here we also have the factor n plus 1 factorial. So the factors will cancel each other out. And so what's left would be n plus 1 for the top here, and then the bottom here would be just n plus 2 times n. And then we end up with n plus 1 over n squared plus 2n. So the limit of the ratio a sub n plus 1 and a sub n be the limit of n plus 1 over n squared plus 2n as n approaches infinity. And so right here, what we can do is divide everything on the top by n squared, and then divide everything down here by n squared. N dividing by n squared, we get 1 over n, and then here we get 1 over n squared. And then n squared dividing by n squared is 1, and then 2n dividing by n squared is 2 over n. As n approaches infinity, the 1 over n approaches 0, 1 over n squared approaches 0, 2 over n approaches 0. And so we get 0 divided by 1, which is 0, which is less than 1. And therefore the series with the expression n over n plus 1 factorial converges by ratio test. Recall that the ratio test says that if the limit of the ratio a sub n plus 1 and a sub n, if this ratio is less than 1, then the series converges. And now let's show that the series with the expression n over n plus 1 factorial show that it converges to 1. Note that n is the same as n plus 1 minus 1. And then we can rewrite this expression here as n plus 1 over n plus 1 factorial minus 1 over n plus 1 factorial. N plus 1 factorial is the same as n plus 1 times n factorial. So for this ratio here, we get 1 over n factorial. And then this is minus 1 over n plus 1 factorial. So the series with n over n plus 1 factorial can be rewritten as the series with 1 over n factorial minus 1 over n plus 1 factorial. And now let's write the partial sum, the sum of the first k terms. When n is 1, we get 1 minus 1 over 2 factorial. When n is 2, we get 1 over 2 factorial minus 1 over 3 factorial. When n is 3, we get 1 over 3 factorial minus 1 over 4 factorial, and so on. The kth term, replacing n with k, then we get the kth term. And then the term before, replacing n with k minus 1, replacing n with k minus 2, and so on. And then we can see that the minus 1 over 2 factorial and 1 over 2 factorial, these will cancel each other out, and then these will cancel. So eventually this will also get canceled out. And then same thing down here. So what's left is 1 minus 1 over k plus 1 factorial. So this is the sum of the first k terms. This is our series. And so the series is the same as the limit of s sub k as k approaches infinity. And so we get the limit of 1 minus 1 over k factorial as k approaches infinity. And as k approaches infinity, obviously this term here will approach 0. So we get 1 minus 0, which is 1. And therefore the series within with the expression n over n plus 1 factorial converges to 1. And that's the end of the video.